All right, we'll start going through some of the options. I'll be looking at the little screen. You guys can look at the big screen. You'll see my big fat finger up there to highlight stuff. Basically what you'll see is when we told you didn't need a MagnaHelic any longer, this is now your current, this will be the MagnaHelic. It's an actual gauge, it's real time, it's running all the time. If they want to see it, it's just on the main screen of the control. It monitors, and you'll see the needle moves up as the pressure goes across, just like a normal mag gauge would. In addition to that, we offer a digital display of what the static pressure is across the filters. It's labeled inches water column static pressure, and down below that you'll see where it says 0 CFM. That's where you'll actually see a real-time CFM reading for the collector. Across the bottom you have your main set of buttons. These are the main options that you'll be utilizing. I think we'll go ahead, we'll turn it on, we'll let you see how it works, and then we'll start walking through all the options. Turning it on, it's pretty simple. You hit the run button. Go over here to the motor. You can hear the pulsing take off. It's set at 40%. I'm going to turn it up to 100%. I told you it was a slow start. It doesn't spike your electrical. It's running up to speed now. It's going up. It's currently running at 100% of the full RPM of the motor. Full RPM 3540. It's running 35, 35, 35, 36. It's running at 60 hertz, which goes to show you, I mean, it's showing you your frequency. This is a variable frequency drive down here. This is what's controlling. As you change the motor speed, that's the number it's controlling. It's the frequency of the motor. It's showing you the amp draw of the motor as it runs right now. So it'll be a little easier to talk over. I'm going to slow the motor down to roughly 40%. A little easier to hear. It's that simple to control the motor speed. If you want to directly control the motor, there it is. You know, if you want to go in and do your cost justification based on 80% of the motor speed, you go in and we'll just set it at 80%. And you'll have 80%, that's where it's going to run. Same screen. This is where we will control the CFM. Let's say, let's go in and make sure my motor is set up. I'm going to run through this real quick so I can show you the CFM, then we'll go back through the screen so you can see what all is going on. Let's say we want it to be 1500 CFM. Now it's in RPM mode, but I'm going to switch it over to CFM mode. And you'll hear the motor go down. It's running down at 40 hertz. And you can see here it's trying to stabilize. What do we say, 1500 CFM? Is that what I put in? It actually, because of the way the control works, it's going to dip down until it reaches a point and then it's going to come back up. It's just in the way that it stabilizes itself and the time delays in reading things. But it'll work its way back up here in just a second. Oops. Set of 2000. But it goes through and it monitors where it's at. I don't know how many of you can see it, but in the duct run behind the collector, the way we've chosen to do this is it has an orifice plate. It's a plate with some resistance. It's a little slightly smaller than the ductwork, and it measures the static drop across that plate. That's how it determines what the CFM is. That allows us to go through and use the same system for a 5 horse, 10 horse, 7.5 horse, custom 7.5 horse, 15 horse, 20 horse, 25 horse, 30 horse. It doesn't matter what blower it is, or if the blower is spec'd out for higher static, lower static, that blower can change. We don't care. We're measuring the airflow through the ductwork. And you can see it back there. Trevor, just take that cardboard and cover up that lower. Either one, I don't care. We're talking about maintaining CFM. Hear the motor change? The motor's speeding up to maintain the CFM. You go ahead and pull that off. The motor adjusts itself, all based on whatever you put in as that value for CFM. We're working our way back down to 1500 because that's why I changed it. It's that simple to go in and set up your system for the CFM you want. You now don't have the motor running too fast, sucking too much air, harming your filters as you're starting up the collector. You have the CFM you want from day one. Go ahead and shut it off. I'm going to run through the other stuff that you can and can't do with it. Basically, you're looking at the main screen right here. You've got your static, you've got your CFM, you've got starts, stops, you've got an access to other pages. The motor we kind of looked at, it's giving you the ability to adjust the motor based on purely on what you want it to be on a 0 to 100% scale of the speed that you want it to run at. So if it's a 3450 RPM motor, you can tell you want 50% of that, you can tell it whatever level you want. You got the amps, display information here, pulse settings. Currently my pulsing is set at 0.071 second on time, 5 second off time, and I have my after pulse set at 0. This is a display only screen, and the reason it is, I know that there are times where you don't want people to mess with what you've set up. There are controls in place so that they can see this information but may not be able to adjust it. So that you don't have the guys running the unit coming over and messing with the controls. There's a way to lock them out with codes that you can go in and just say, I'm this level of code, I can make these changes. So we're displaying information you can't necessarily change from here. We go on to the next one, that's pulsing. Under system setup, these are the model selections available. We've currently set this thing up for all of the RP series, RP2, 4, 6, 8, all the way through. We also have an option just to shut pulsing off completely. That's the no pulsing option. I'm not sure why you'd want to do that, but there may be maintenance issues where you want to shut down pulsing. That's available. It's something you can do. Under motor selection, it's set up to run on the 5, 7, 10, 15, 20, 30 horsepower options. Those are the options that you have available. On the diagnostic screen, you have the model of unit you have. You'll have the horsepower available. You'll have the voltage available, RPM available, the amp draw available. This information is the information that if they called in and said, I've got something's going on with my collector, I want you to tell me what's going on. We would tell them how to get to this screen and look at this screen, and we could help diagnose because we have all the information available as far as what's going on with this collector. There's a second page of diagnostics available, total run hours, max current amp draw, that would show if for some reason they have made some changes or had the wrong voltage or something, and they tried to hook up and run it at amp draw above what we've preset here, it wouldn't be able to do it. And we can go in and look and see this is the max output of amps that they've ever gotten out of this collector. Power consumption, again, that's just a simple number that it's keeping track of in here. that says this is the total power consumption this unit has ever used. You could use that and compare it to, running at 100% and say, okay, it could have used a total of so many megawatt hours. It actually has used 5 megawatt hours. There's your cost savings. The last thing on here is the orifice plate. Again, I'm talking about what's back behind the collector in the ductwork. There's that big round circle. That's the orifice plate. The way we're measuring the CFM is the resistance through that orifice plate. You come in here, you tell it it's a 10-inch orifice plate. You can put in whatever number you need to based on the ductwork size you're utilizing, but that's how it determines CFM. Now, the last little feature I wanted to show you, right here on the main screen is parts info. We get calls, people not knowing the parts, not knowing the filter numbers, not knowing what they would want to know. For example, if I have a rotopulse and somebody wants a new bearing for it, you can simply go into rotopulse. You'll see a drawing that shows you the rotopulse and all the components that are associated with it. And let's say, for example, I know I want this bearing down here on this end. Okay? I can see the bearing on that end. I know I think I want that bearing number 28. Well, number 28 is a 3595 bearing. Okay? You can go in and you can see your components. If you want to see the rototube, number 26 is a rototube, or you can see the one for the RP2, because this is available for the RP2. You need a new pivot pin, or you lost your spring or something. Number 21 is the compression spring, 2285. Okay? And we'll go back out. Let's say I know I need to order filters, but I don't know my filter numbers. There's my filter number. Last but not least, I've got it installed. I got some questions. I'm not sure if it's running right. Does anybody use the troubleshooting guide on our website? This is pretty much the same troubleshooting guide that walks you through step by step, trying to decide what may or may not be wrong. Is the unit installed? Yes. Is the unit running? Yes. Is the motor blower running in the right direction? Yeah. The unit will suck air even when running backwards. Is the blower rotating in the right direction? And that's in there twice because you always get the wrong answer the first time. Because they say, of course it is. Okay? No. Switch any two wires. It gives you kind of some brief instructions on how to fix that problem. Okay? We'll go back. We'll say, yes, it's running correctly. Yes, it really is. Is the rotopulse operating correctly? Now let's say no. Well, do you have air pressure? Are the solenoids wired? Do you have power to PLC? Do you have power at the drive? Maybe your photohelic was turned on and you think it should be pulsing, but you've got your photohelic running. Pulsing has been disabled. There's an option to disable pulsing. This will help you troubleshoot maybe things that will help you walk through. It'll help you if you're on the job site, easily go through and say, I can find the problem. It'll help the customer. Again, if you're on the rotopulse and you think you might have troubles there, you can go straight over to the drawings and say, okay, well, I got in there and I was missing that part. So there we go. We're back to the main.